Anybody not able to locate that in the notes? Okay, so we're going to be talking about the metric system. The metric system is based on the power of 10. I'm sure many of you have had some experience with this in the past. The metric system is, so you need to be in the notes section here. So you're going to go back over to here where we're taking notes, and it has a chart. It says base unit. It's on the very back side of the first page. Okay. Right. All right. So the metric system is used by the industrial world except for the United States. We don't use it because we're kind of stuck in our old ways. People have just never wanted to change. They tried back in like the late 70s, early 80s to get people to change. That's where you started to get things like a 2-liter bottle. You started getting your nutritional labels listed as milligrams of sodium, or you need to take this many milliliters of this medication. So they started to try to kind of force people over into it, but the American society was very resistant and stubborn. And so about the only place that you see it used is in the scientific community. We use it. Most of our lab equipment is based on this. It's much easier to work with than the standard system that we currently are working in. For example, if you're working with recipes and they're calling for 2 cups of something and you want to make a big, large amount of that, you know, how many gallons would that be? I have no idea how many cups are in a gallon. Okay, I would have to look it up. Here, if you want to figure out how many milliliters are in a liter, all you have to do is shift the decimal point. Okay, so you don't have to know, okay, there's 3 teaspoons and a tablespoon, there's 2 cups and a pint, there's 2 pints and a quart, there's 4 quarts and a gallon. It's just all over the place with the American system. Like to have all of that stuff memorized, it's just easier in the metric system to shift that decimal. But people were very resistant to it. Our tools are still in inches, are still in, you know, like if you go out to your garage, you might have tools that are like a 1/2-inch crescent wrench, or not crescent wrench, I guess, because they're adjustable, but a 1/2-inch wrench. But you may also have millimeters out there. Now, why do people end up having to buy tools that are in millimeters? Well, because we got a lot of products in from other countries that are done that way. So you're getting in a car from Germany, a Volkswagen that you're working on, you need to have the tools to be able to work with that. So that's why typically people here in the US will probably have 2 different sets of tools. Now I do a lot of sewing and quilting and that sort of thing. So all the stuff in there is in inches, and that's what all of my measurement tools at home are in. But I can tell you, when I want to work with stuff, I like to use centimeters instead because they're much more precise than a whole inch. Okay, so there's good things about the metric system. If you're measuring out recipes, oftentimes if you don't have a conversion for something, if you're working with something from Europe, they'll oftentimes give you the amounts in grams, and you can use a balance and a scale. I have just a cheap $10 kitchen scale that I use, but it's much more accurate than trying to measure on a cup, because a cup of flour can vary if you get some air pockets in there. And if you want a very precise measurement, go with working with grams. It works out much better. Okay, so base units. When we work with the metric system, we have what's called base units. We have for time, they're seconds. And you might have heard of like a millisecond when they're talking about like athletes, swimmers in the Olympics. And there might be a millisecond that separates the gold from fourth place. Okay. Meters. You might see signs for kilometers. We use centimeters in here all the time. Grams, that's what we use for our balances when we weigh out things in here. We have temperature in something called Kelvin. And then the amount of substance is in something called a mole. And as we move through the year, we will end up getting into that mole and determining what that is. This is what we work with as far as our base unit. So our base unit falls into here, and then we just, you can see where they're just moving the decimal point up or down. Okay. When we do metric conversion, and in here for this chapter, we're just going to go from kilograms down to milligrams. Okay, that's the only part of the metric system that we're going to worry about in here, is this from here to here. We'll work with some of the rest of this as we move through the year, but this is our focus, is between kilo and milli. Okay. So when we do that, we need to know where we're at on this scale to be able to slide that decimal point back and forth. So we start with kilo, and that could be a kilogram. It could be a kiloliter. It could be a kilometer. We then move to hecto. Then we move to deca. This is our base unit. Then deci, centi, and finally milli. There are 10 of these in every one of these. There's 10 of these in every one of these. So there would be 100 of these that make up this. Does that make sense? This is our base unit. This is where you would have your meter. You would have your gram. You would have your liter here. You might even have a byte here, B-Y-T-E. You've heard of a kilobyte? Okay. So data is even measured in this when we're talking about computers. All right. So this is our base unit. Then we have our deca, our hecto, and our kilo. All right. How do we convert using this? And how do we remember these? So there is an acrostic, something like that, that people use, a mnemonic device, we'll go with that people use to memorize this. And that is King Henry doesn't usually, and that is for base unit, drink chocolate milk. So if you're trying to remember these prefixes, that is what you can use to help you remember them. Okay? All right. So our first one here is going to use the gram. So that is going to be our base unit. So our base unit is the gram. We're starting at 15.2 grams. So we're starting here and we're going up to kilograms. So what you need to do is you need to locate where your decimal is. So in this case, it's 15.2. We're going to find where we're starting, and we're going to count how many steps it takes to get to where we're ending. So here, we're going to go 1, 2, 3. I'm going to move my decimal point 3 spots. So I'm going to move 1, 2, 3. What do I need to fill in this loop with? A 0. So that becomes a placeholder. I moved my decimal the same number of spots and in the same direction that I moved to get from where I was going to where I'm getting to. All right, let's try the next one. The next one is milliliters. So we're starting here and we're going to where liters would be. This is my base unit. Liters would belong here. So how many steps am I taking to get to liters? 3. I'm going to go 1, 2, 3. So I'm going to move my decimal. 587.65. I'm going to move it 3 spots. So I'm going to go 1, 2, 3. My decimal is going to be here now. So my answer is 0.58765. All right, next one. See if you can do the next 2 here. Talk to the person next to you. See if you can do the next 2. I think we said everybody was here. I don't think I've done my attendance yet. Everybody but Josie. Nope, nope, it's just right up here. So just write it off to the side. See if you can do it. Anybody need more time? No? All right. So here, our grams are going to be here. We're starting at milli, and we're going to move our decimal point 3 spots this direction. So your answer should have been 0.0152. Here, for this guy, we are moving from meters, and we're going this direction to get to centimeters, and I need to go twice. So this should have been 84.5. Easy enough? Everybody okay with that? I think that's all I had. Yep, that's it for today.